First law, laws of exponents and powers. First law is a raised to m into a raised to n is equal to a raised to m plus n. When we multiply two numbers in its exponential forms, that is a raised to m is in its exponential form where m is the power and a is the base. A raised to n is in its exponential form and n is the power, a is the base. When two numbers in exponential forms are multiplied, then the powers are added because the base are same. In multiplication of exponents, when base are same, powers are added. That is 7 square, for example, into 7 raised to 3. Here 7 and 7, the numbers are same, but powers are, the power of 7 square is 2 and 7 raised to 3 is 3. Here 2 and 3 are added. Only powers are added because base are same. 7 is the same number. Then 7 raised to 2 plus 3. This is equal to 7 raised to 5. We can verify it. See, 7 raised to 2 is 7 into 2, right? 7 raised to 3 is 7 into 7 into 7, right? When you multiply these two numbers, we are multiplying 7 5 times and it is same as 7 raised to 5. Is it not verified? Now the second one. A to the power m divided by a to the power n is equal to a to the power m minus n. In division, when base are same, powers are subtracted. Here a and a are same. Powers are m and n. We subtract n from m. The power of the denominator is subtracted from the power of the numerator. Okay, this is very, very important. Here 7 raised to 3 divided by 7 raised to 2 is equal to 7 raised to 3 minus 2. That is 7 is equal to 7 raised to 1. We can verify this. What is 7 raised to 3? 7 into 7 into 7, right? What is 7 square? 7 into 7. So this is normal division. This 7 cuts with this 7. This 7 cuts with this 7. That is, when there is a division of same numbers, we get 1 as quotient. We are left with 7 to the power 1. Is it not verified? So, with such small examples, you can understand the generalized form. In division, when base are same, powers are subtracted. Now the third one. A to the power m whole to the power n. See, here a is raised to m. You will get some value, then that value is raised to n. This is called power to the power. This is equal to a raised to m into n. Here we multiply these powers because the exponential form is raised to another power. In that exponential form, m is the power. And when that form is raised to n, we will multiply these two powers and we write it as a to the power m into n. See, 7 to the power 3. We can understand this by an example. 7 to the power 3 bracket raised to 2. Why we put this 7 raised to 3 in bracket? Because this exponential form of this number has some value. That value is raised to 2. Then we multiply the powers. That is 7 raised to 3 into 2 is equal to 7 raised to 6. We can verify this. See, 7 raised to 3 bracket raised to 2 means what? This the quantity 7 raised to 3 is multiplied 2 times. 7 raised to 3 into 7 raised to 3. When two exponential forms with same base are multiplied, the powers are added. 3 plus 3 is 6. Are they not same? We are proving this by using the first law of exponent. And it is made the third law of exponent. Because every time in generalized forms or when you have big values, we cannot do this addition repeatedly, and repeated addition is always multiplication. Therefore, 7 to the power 3 to the power 2 is 7 to the power 3 into 2 is equal to 7 into 6. In general, a to the power m whole raised to n is equal to a raised to m into n. This is equal to a raised to mn. Got it? If you have any doubt, please ask me in the comment section. Then, when an exponent is raised to power, powers are multiplied. Now the fourth one. A to the power 0 is equal to 1. For example, 7 to the power 0 is equal to 1. Take any number, 75 to the power 0 is 1. Take another number, 745 to raise it to the power 0. The value is always 1. It is defined. And you can learn in your next classes, and we can prove it also. So any quantity to the power 0 is equal to 1. Okay. Now the next one. What is the fifth rule? Here powers are same. See, base are different. A to the power m and b to the power m. These two quantities are multiplied. When this situation arises, we multiply the base a and b. Then the product is raised to the same power. That is ab raised to m. For example, 7 square into 5 square. Here 7 and 5 are called base. 2 and 2 are called powers. Power are same. Base are different. Then what we do? We multiply the base. 7 into 5 and raise it to the power 2. That is 35 raised to 2. You can verify it and play with these numbers. Okay. First find 7 square. Then find 5 square. Multiply them. Find the product. Okay. Then multiply 7 into 5. That is 35. Find the square of 35. You will get some value. Then you will be surprised to see that this value is equal to this value. You can verify taking different numbers. You can play with these numbers. This is how you should be perfect in mathematics. When exponents with same power to different base are multiplied, product of bases is raised to the same power. Now the next one. When two exponential forms are divided with the same power and different base, a to the power m divided by b to the power m. Here base a is different from base b. These two bases are different and powers are same. In this case, we see that take the quotient of these two base a upon b. Then that quotient is raised to m. For example, 7 square divided by 5 square. We need not find 7 square and then 5 square and then take the division. It's easy to write 7 upon 5 bracket raised to 2. Here the quotient of base 7 and 5 is taken and it is raised to power 2. And 7 upon 5 is known as 1.4 bracket square. Now it is easy to find the square of 1.4. Then taking square of this, taking the square of this, again taking the division. You can verify it by simplifying the left hand side and the right hand side. You will see that LHS is equal to RHS. When exponents with same power and different base are divided, quotient of bases is raised to the same power. Now the next rule. What if the power is negative? Specifically, a to the power minus n. Then we take the reciprocal of the base. What is the base here? A. What is the reciprocal of a? 1 upon a. And that value is raised to the positive power. This is equal to 1 upon a raised to n by the second rule, right? See, this is the second rule. What it says, a to the power m divided by a to the power n is equal to a to the power m minus n. Sorry, this is fifth rule. Sorry, sixth rule. A upon b to the power m is a to the power m divided by b to the power m. This is the reverse of this formula. Law. For example, 7 to the power minus 2 is equal to 1 upon 7 whole raised to 2. That is 1 raised to 2 divided by 7 raised to 2. This is equal to 1 upon 49. Okay, got it? Here, using this law, when base are different, here 1 is different and a is different, we raise same power to numerator and denominator. 1 raised to n is 1 only. This is equal to 1 upon a raised to n. Okay. If you have any doubt, please ask me in the comment section. If you have a negative power, then reciprocal of the base is taken and the power is become positive. It is 1 upon a raised to n. When a base is raised to negative power, the reciprocal of the base will be raised to its positive power. Then the eighth one, the same. It is the next step of the seventh law. A upon b whole raised to minus n will be b upon a raised to plus n. The negative power will be changed to positive power and the base is changed to its reciprocal. For example, 7 upon 3 raised to minus 2 is equal to 3 upon 7 raised to 2. And this is same as 3 square upon 7 square. But this is easy to calculate. Got it? Now the next rule. What if the power is a fraction? A to the power half is square root of a. That is 7 to the power half is equal to square root of 7. If power is a fraction, the base is raised to the value of numerator and the denominator root is taken. It means a raised to 1 upon n. Here base is a. Okay. And this base is raised to 1 upon n. A raised to 1 upon n. This is equal to nth root of a to the power 1. A is raised to 1 upon n. So, nth root of a raised to 1 is calculated. In generalized form, a to the power m upon n is equal to nth root of a to the power m. Here, numerator m is taken as the power of the base and denominator is n is taken as the root of that product. Root of that exponent. A to the power m is an exponent and nth root of that value is calculated. A is raised to m upon n. So, nth root of a to the power m is calculated. 49 raised to half is equal to square root of 49 is equal to 7. That is square root of 49 is equal to square root of 7 square. And it is equal to 7. 343 to the power 1 upon 3 is equal to third root of 343. That is third root of 7 cube. This is 7. Now the last one. If a to the power m is equal to a to the power n, then m is equal to n. If some exponential form is equated to the another exponential form with the same base but powers are different, Different means they are written in different forms than m is equal to n. For example, if 7 raised to x is equal to 7 raised to 3, then x is equal to 3. And a raised to m is equal to b raised to m. Here powers are same, the base are different. Then a is equal to b. They cannot be different. Here powers cannot be different. They are same. These are used to solve some examples. A raised to m is equal to b raised to m. Then if this is the condition, then a is equal to b. Then base should be the same. When you equate two exponential forms with the same powers, then the base should be same. For example, if x square is equal to 7 square, then x is equal to 7. So this is all for laws of exponents and powers. We'll understand more when we solve exercises given in the textbook and some more examples. Okay.